So you've got a VPN. You click connect and you feel that little bit of relief, right? You assume you're protected. But are you really sure? We put a whole lot of trust in these services, and honestly, that's trust that needs to be verified. In this explainer, we're going to run through a super simple 4-point check to make absolutely sure your VPN is doing what you pay it to do.
And that really is the heart of the matter, isn't it? You're using this tool, paying for it, to build a digital fortress around your life. But what if it's not a fortress at all? What if it's just a cardboard wall, giving you a false sense of security while everything is still exposed? Well, we're about to find out. All right, first up is the big one, the absolute foundation of any VPN. This test checks the #1 reason you're using a VPN in the first place, to hide your real location. Honestly, if this one test fails, nothing else even matters. Just think of your IP address like your home address, but for the internet. It tells every website you visit exactly where you are. A VPN is supposed to act like a secure post office box in a totally different city. Its job is to replace your home address with its P.O. box address. We just need to make sure our digital mail is actually going to that P.O. box and not getting delivered right to our front door.
Now, this is a test you can do in, I'm not kidding, less than 30 seconds. First, make sure your VPN is turned off. Go to a site like whatismyipaddress.com. Just take a quick note of what you see. Then, fire up your VPN, connect to a server somewhere far away, say in Germany or Japan, and then just hit refresh on that same website. So what are we looking for here? A success means you see a brand new IP address. The location should match the server you picked, and the ISP, well, it shouldn't be your home provider. It should be some generic data center. But if you hit refresh and you still see your original IP address and your normal internet provider's name, that is a total failure. It means your VPN isn't masking a thing. Okay, so let's say your IP address check passed. Great, that's a fantastic start. But that's not the whole story. Sometimes tiny bits of data can, well, escape the secure VPN tunnel. These are called leaks, and now we're going to go hunting for them.
Think about it like this. When you type in a website, your computer has to ask for directions to get there. That's a DNS request. Your VPN is supposed to handle that request privately inside its secure tunnel. But a DNS leak? That's when your browser just ignores the VPN and shouts its request out loud to your regular internet provider for anyone to hear. It's a huge privacy oops. And you know what? Testing for this is also incredibly easy. With your VPN connected, pop over to a site like dnsleaktest.com. You just click the standard test button, let it do its thing for a few seconds, and it'll show you a list of all the servers your computer is using to get those directions. Now here's how you read the results. You're safe if every single server on that list belongs to your VPN provider or maybe a neutral third party. But if you see your home internet service provider in that list, Comcast, AT&T, Verizon, whatever it is, yep, you've got a DNS leak. But there's another sneaky kind of leak we need to check for called WebRTC. It's a technology that's built right into browsers like Chrome and Firefox, and it's used for things like video chats. The problem is, sometimes it can get a little too chatty and just blurt out your real IP address, completely sidestepping the VPN. And checking for this one is maybe the easiest of all. Keep your VPN on and just go to browserleaks.com/WebRTC. You literally don't have to click anything. The test runs the moment the page loads. You're just looking for one specific field, public IP address. The verdict here is about as black and white as it gets. If the public IP address it shows is the same one your VPN is giving you, you are all good. You're safe. But if you see your actual, real deal home IP address sitting there in the results, that, my friend, is a WebRTC leak, and it's a serious vulnerability. So, we've checked for leaks while everything is running smoothly. But what about when things go wrong? What happens if the connection drops? That is where your last line of defense is supposed to kick in, the kill switch. And we have to make sure this failsafe actually does its job when it counts. So, what exactly is a kill switch? Well, think of it as your digital emergency brake. If your VPN connection unexpectedly drops, even for a millisecond, the kill switch is designed to just, bam, instantly cut off your entire internet connection. This is so your computer doesn't automatically try to reconnect using your regular, unsecured home network, exposing everything you were just doing. And we can actually simulate this failure pretty easily. First, go into your VPN settings and make sure the kill switch is turned on. Then connect to a server like normal. Now for the test. Quickly toggle your computer's Wi-Fi off and then right back on. In that split second while the VPN is scrambling to reconnect, try to load a new website. And this right here is the whole philosophy behind it. It is so much better to have your internet cut out for a few seconds than it is to have it silently switch over to an unencrypted, totally exposed connection without you even noticing. A kill switch chooses safety over convenience every single time. So here's what you look for. If that kill switch is working properly, the website will absolutely not load. You should get a no internet connection error until your VPN is back up and secure. But if that page starts to load, even for a second, your kill switch has failed and your data was just exposed. Okay, so what happens if you ran one of these tests and, you found a problem? First thing, don't panic. Let's really quickly go over some simple, immediate things you can do to plug those leaks and get back in control of your security. First, and this is the most important one, update your VPN app. Developers are always fixing security holes in new versions. Second, do a little digital housekeeping. Clear your browser's cache and cookies, since they can sometimes hold on to old data. Third, you can flush your computer's own DNS cache. And finally, for the more advanced crowd, if you know your VPN doesn't support a protocol called IPv6, disabling it in your network settings can often stop a lot of stubborn leaks. At the end of the day, this all comes down to one simple idea. Don't just trust, verify. These tools are free. These tests take just a few minutes, and they give you the power to make sure you're actually getting the privacy you're paying for. So the real question is, are you ready to take control and check for yourself?